We're going to determine if this series is convergent or divergent, and if it converges, we'll find the sum. So first thing we always check, because it's the very easy check, is the divergence theorem. So we're going to let n go to infinity and look at the terms in this series, and we see that this numerator is fixed, denominator going to infinity would have the terms in the series going to 0. So we really don't know anything. If this had not gone to 0, we'd have known it diverged, but if it does go to 0, we don't know anything. So we're going to have a look and see what else we could look at to maybe tell what's going on with this series. Well, I see that that denominator factors, and I could factor that, the difference of squares, and then I'm going to use partial fractions to split this up so that I can look at what's going on in this series. So I'm going to do that down here. We have 2 over n plus 1, n minus 1, and we could split that up into partial fractions, a over n plus 1 plus b over n minus 1. Now let's go ahead and clear this of fractions, so we'll multiply everything by n plus 1, n minus 1. That'll cancel there. It'll cancel the n plus 1 and leave an n minus 1. Cancel the n minus 1 and leave an n plus 1. Now let's conveniently let n equal negative 1. And that would zero this out. That would make this negative 2a equals 2. So a is going to be negative 1. Then we will let n equal 1. That will zero out the a term, and we will have 2b equals 2. So b equals 1. So we could split this series up, and it would look like the sum as n goes from 2 to infinity of negative 1 over n plus 1 plus 1 over n minus 1. Now let's write out some of the terms of this series so we can see what's going on. Now I'm actually going to reverse these because I'm going to have the positive one be first. So maybe I'll go ahead and rewrite it so we can easily see what I'm doing. So we're going to start with n going 2 to infinity. We're going to have 1 over n minus 1 minus 1 over n plus 1. Okay, that should really be in parentheses. Okay, so let's go ahead and put in 2. When I put in 2, I have 1 over 2 minus 1, so I have 1 minus, when I put a 2 in here, I have 1/3. Now let's put in a 3. 1 over 3 minus 1 is 1 over 2. Putting a 3 in here, we have, and this was a minus, we have 1 over 4. Now putting in a 4, we have plus 1 over 3 and then minus 1 over 5. And we can kind of see, if we continued, we can kind of see the pattern or what's going on here. But this starts as a 1, then a half, then a third, plus a fourth, minus, this would be, so we look here, this went 3, then 4, then 5, so this would be a 6, and so forth. Now if we go to the, let's go to the n minus 1 term and then the nth term. So the n minus 1 term, putting an n minus 1 in here, would be 1 over n minus 2. So there should be a dot 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 in here because this continues in the middle, and then we're going to have a dot 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 after as well. Putting an n minus 1 in here, this would be minus 1 over n, and then putting an n in, we'd have plus 1 over n minus 1 minus 1 over n plus 1 plus 1, and then our dot dot dot. Okay, so what do we have in all of this? We actually have a telescoping series. You see that this term will cancel with this term with this term, and we could continue like that. So as we looked here in this first piece, this second one canceled here, and then after we got over to here in the first one was what we canceled from over here. So all of these middle terms will collapse down or cancel out, and we will be left with this first part on these two, and we will actually then be left with the last piece on these two. So what we are going to do then is look at the limit as n goes to infinity, and we will have 1 plus 1/2, and all that middle stuff canceled out. and then we have minus 1 over n and minus 1 over n plus 1. Now as we let n go to infinity, we see these two pieces are going to 0, and we can add the 1 and the 1/2, and we can see that this converges then to 3 over 2.